Hi, my name is Tom and you are at level 32 of mastering Einstein's special relativity. Faster than light. This video will be totally different from all other videos on this topic. In fact, I will not go that direction. This will be something completely new. Curious? Let's go. So before I reveal what this video is about, let me tell you what it isn't about. And these are the topics you will find online. Great videos, by the way, but that's not what I am going to do as well. I'm not going to talk about how light slows down when it travels through a medium. And if you have two light beams, one in vacuum and one through a medium, then this one will win from this one. And you could say whatever is traveling here through the medium, through the vacuum, is winning from the light through the medium. I'm not going to do that. I'm also not going to talk about planets that are moving away from us faster than the speed of light. Why? Because it's not actually the traveling, it's space itself is stretching. And in special relativity, we will not stretch space-time. So therefore, we're not going to talk about this. We're also not going to talk about that the distance between different objects, fast-moving objects, can decrease or increase more than c meters each second. And in level 31 we had two rockets flying 80% at the speed of light going head to head, and from our stationary perspective that distance between the two rockets actually decreased 1.6 c meters every second, but nothing was moving faster than the speed of light. We're not going to talk about quantum entanglement. Why? Because I don't master quantum entanglement and I'm not a professional, so I'm going to leave that to the real professionals. We're not going to talk about curved spacetime. I just talked about stretching, but you can take spacetime and you can bend it in all kinds of different shapes. That's not what we are going to do. We're not going to talk about warp drives. As I'm taping this, it's now April 2021. Some papers came out that open up new possibilities on warp drive. So true professionals in this field are now, as we speak, putting out videos on warp drives. Exciting stuff. I'm not going to talk about how you would need an infinite amount of energy to push mass past the faster than speed barrier, and of course we don't have infinite mass, so we can't never do this. And I'm not going to talk about relativistic mass. If you've never heard about relativistic mass, keep it that way. Okay, so what is this video about? It's about real world special relativity. And with real world I mean we are going to pick up our video camera or our mobile, our cell, and tape fast moving objects and discuss what we will see. And in levels 27 and 28 we already revealed some of that stuff. We know from Einstein that fast moving objects actually shrink. They do. So what happens if we tape that on video? Then we discover that objects coming at us will be stretched instead of contracted. And objects moving away from us on the video, they will seem even further contracted than the classic length contraction given by Einstein. So these videos will be deceiving, but this is what we already know. So what am I adding in this clip, this video? Here we go. Videotaping a fast-moving object coming at you will look faster than it is. How much faster? Let's give you an example. Let's say we have an object traveling towards you at 80% of the speed of light. So its velocity is 0.8 c. On the video it will look like, boom, 4 times the speed of light. 4 times. So let's say you wouldn't know this and you would have actually taped this object. You would say, I found an object that traveled 4 times the speed of light. Well, in fact, it only traveled at 80% of the speed of light. that same object, when it leaves you, will look on the tape to move slower than it actually is. In this case, 0.444 times the speed of light, instead of the 0.8, which is the real number. There's even more. Objects coming at you will look further away on the video. And this makes sense, right? For stuff to film on your video, you need light bouncing off the object you're filming. That light takes some time to travel to your camera, and during that time the object itself is also moving a little bit towards you. So let's say you look into space with your telescope and you see a huge scary monster alien coming at you to eat you alive. You might say, don't worry guys, it's still miles away, while in fact it's already in front of your face, but you don't see it. This is what happens when fast moving objects come moving towards you. And if they move away, they seem to be moving closer. They seem to appear to be closer. So let's say the monster passed you and you want to hit the monster with a stick. You are hitting air because the monster is already gone. So these are pretty, I would say, fascinating phenomena that happen when you try to make it real world by introducing your video camera. And what do you get in return? You get anything but the real world. You will be deceived. Let's see the movie. I cheated a little bit. In this case, for the true professionals that are watching, I ignored all the Lampa, Penrose, Terrell, rotational thingies going on. I just focused on the stuff happening in the direction of motion. And, you know, I did this assuming the calculations are based on a one-dimensional rocket. Well, a one-dimensional rocket is a pretty boring rocket, so I introduced a real three-dimensional rocket in my clip. But you know, this doesn't change the overall conclusion that much, like 0.00001% or something like this. So, but you know, just to make it complete, this is what I ignored. So here we see our rocket. It is moving towards us. The video still stopped now. The yellow dots tell us where the front and the back of the rocket is. Yeah, it's projected on our measuring strip with the green lines equally spaced there. So now I'm going to start the animation. You will see the rocket move. And it looks a little bit stretched, right? Because this is the videotape. The real rocket will be a lot smaller than this one. And see what happens with the tip of the rocket when it passes the red line. The red line is where we are. You see it starts to move slower. And once the back of the rocket also passes this line, the back also starts to move really slow. And now we see it leaving from us. Its length has been decreased a lot. And it's moving a lot slower. And this is what we all see on the videotape. And it's not true. Although we saw it with our own eyes, it's not true. Summary of the secrets. When we videotape fast-moving objects, approaching objects will be larger than they actually are, faster than they actually are, and more further away than they actually are. And fast-moving objects moving away from us will look smaller, slower, and of course closer to us. So this is what you get when you try to film the evidence. Let's say you were a beginning physicist and you made actual movies of galaxies moving around you through the universe, and you would go to Einstein and say, Einstein, look at this, it's 4 times faster than the speed of light. And let's say Einstein didn't come up with his special relativity back then you would get a very interesting discussion, right? And even after Einstein did it all, you would get an even more interesting discussion. How come the stuff on the video does not match our theoretical model? And we know, we know that the theoretical model is for these cases is absolutely true and the video is wrong. This is it. This is the level A. In the B level, let me go one back. In the B level, we will do this using the space-time diagram. Then you can actually see with your own eyes why the video is lying and it's not telling us the truth. In the C level, we will actually derive the equations for these phenomena if you want to. So, now I'm going to close with this one. I do it all my episodes. This is all the levels I've created. You are free to dive in. It builds special relativity from the ground up. The green ones are the must-sees. We have some supporting levels and some optional levels. Here is the second batch, so it's a lot. Just pause the video and see if there's anything there. But for now, I want to thank you for watching and I hope to see you at the B level. Bye bye.